got the shaft right here. When you feel fluid in here, it pushes it backwards. When you feel fluid in here, it pushes it forward, okay? When you go one way or the other, you have to have fluid going in and fluid going out. And that's what that valve does. Okay?
Lord have mercy.
What happened?
You changed a bunch of slides there somehow.
Hit a little scroll wheel problem.
How'd I do that? Well,
Yeah, he had the corner in his hand.
I bet this thing does it.
Probably does.
We tried to make it do it the other day, wouldn't do it. Of course, you don't want to. Okay. Now, you got fluid coming in here, it's pushed fluid out, and fluid has come down through this little symbol right here. Is another form of a flow control valve, which usually is there's one inside the back of the cylinder. Usually there's a little screw back there you can adjust. What this does is afford you to let the cylinder go out fast and come back in slow. You can't do that down here because that controls the flow going to the cylinder. So you have to have an isolated control. And everyone, a decent cylinder has it on the back. Just take like a dump truck. You know, a dump truck dumping it comes up kind of slow, dumping stuff. He wants to come on back so he can go on down the road. So you got two different flows. All right? So when this comes down, and what these components right here can be in one little thing, no bigger than my fist. And they can be combined, but this is telling you what it needs or what is in the line. This is a check valve. And if you look at it, it's another symbol that tells you what it's doing. You see the ball in the funnel? Okay, you got a ball in a funnel. If I drop the ball down in the funnel, I can pour liquid in the funnel, it's not gonna go out. Now, if I turn it upside down, of course, the ball is gonna fall out, and I can pour fluid through the bottom of the funnel. Fluid will go that way, but it won't go this way. So you just keep that in mind when you're looking at that. So what happens when it's pushing this cylinder back, it's letting the flow come through and go by. It's bypassing this little valve and coming back and going through the tank, okay? Now, when we activate the little man and pull it back, and we send pressure up through here, we want controlled pressure. So it comes up through here, and whoop, when it gets right in at 10 gallons a minute, slows down. The speed, the flow, and the volume slows down to the back of the cylinder, so the back of the cylinder goes out slow.
Back pressure on the
Yeah.
backside.
Because this is open. This end will be open, there's no check valve and nothing that going, it's gonna be going straight back to the regulator. And you can regulate, you can't regulate coming back because you're gonna be coming back to the tank. So, that's how you make a cylinder go one way faster and one way slower.
Is that what they call a blow-by valve?
Usually call a blow-by valve on a pneumatic system or board.
Something with steam or air pressure.
Yeah. Usually when you're using gas, but everybody kind of understand how that works. This is a very basic drawing, and it can cover you on pneumatics and hydraulic pretty much. I mean, you can get in a more complicated drawing. It just goes on and on and on and on. Because you can take, in a plant, you can have one hydraulic pump and one hydraulic motor and probably run 15 pieces of equipment. I mean, it's quarter what it's running. It's just amazing what you can do with hydraulics.
That's what we use at work, is a diesel engine for power. We've got the hydraulic pump and then a hydrostat. We run 1, 2, 3, 4. There's about 8 or 10 different hydraulic motors that runs off that one pump.
See, it's amazing. Just like well, that's what the transmission in your car is, the automatic transmission is hydraulic, hydrostatic. I have some of y'all probably, I got a 0-turn mower. And the way that mower operates, is each wheel has its own hydraulic motor. Okay, and each wheel, and this has, each one has its own pump. Okay, there's a pump down here, and then there's a lever going to the valve, and then the lever coming up, and all I'm doing is shunting that valve back and forth, I've done it again.
You done it with my seat again.
Doing on that
Use
remote
it back.
control.
I guess you got through the long one and gave you the rest of it. I didn't do it to the bottom.
Going all the way down. I'm operating one of those valves. It's sending fluid in, fluid out, fluid one, fluid, and it's make the motor is going forward, reverse, and you can't do that with electric motor. You can't do that with gasoline engine. I mean, and you can't, if you take a gasoline engine and put a transmission and sit there and run back and forth like that, I mean, how long is that transmission gonna last? But the reason you can do it with hydraulics is because it's fluid. And actually, without a better description, it's fluid. It operates fluidly. Is that in the word?
Yeah.
But,
Sound good.
sound good anyway. It fluidizes the system.
There you go.
I keep on
Well, let's get
making
away with it.
But, that's how it operates, and it's just a fluid motion, so it's like your automobile, you come to work today, and especially the new ones, I mean, I remember in the seventies, when you want to change the gears, you know, automatic. But now it's just, you know, my car's 8 speed, and I hardly ever feel to change the gear. But, you got the torque converter and the fluid in there, and your valve, it all works on centrifugal force. But, like I'm saying, this is a basic system. It's basically one you should actually study a little bit, go online, look at one of these, and you can take this right here and just about span out and read them all after a while. Now, it does get confusing when you start getting those lines running everywhere and all this. You got, I don't know if we've covered it, but if we don't, I'll touch back on it, but
It's really like if you can read a blueprint, if you know the symbols. that
if you
it
know the symbols,
represents.
you're pretty much set. Okay. Any questions? Remember, like I said, this big line, this is a reservoir, and then that's a reservoir. So just remember, don't let that catch you off guard sometime. You'll see these symbols, with the air going that way and the air going down. We're basically the same. So, just remember this check valve too has a meaning. It shows you that flow can go this way, but it can't go that way. It's a ball and a funnel. The cylinder, that is a double action cylinder. That means fluid can go in and push fluid going back. Sometimes you'll see these and it'll have that little thing that looks like a spring is a spring. You'll see a spring in one. That means fluid goes in one end and the spring pushes it back. So,
But that one is just operated by the flow of the, fluid in it is what pushes it back in that
Yeah.
one?
fluid goes in one end and goes out the other. When your valve, the little man changes. And then when he goes back the other way, fluid comes in this side and out the other, and back to the tank. And another thing this valve does, and I failed to mention, when you stop, you're not doing anything, let's say, you've done what you wanna do, and it's sitting there running, the pump's still sitting there running. This control valve, instead of it sitting there running on deadhead, will it's also set as like a pressure regulator. It'll let the fluid go back to the tank instead of it sitting there deadhead. So it actually does dual jobs.
Just constantly circulation.
That spring actually is set to not let it over pressurize and fluid come back in. Okay, pictorial diagram.
With that process you were just talking about, that will also prevent cavitation, wouldn't it?
Yeah,
I think.
yeah. You cavitate a hydraulic pump, it don't last long it's bad, because it is a possible displacement pump. This is a pictorial diagram. The last diagram is different from this. You're not gonna see this a lot, because it's too easy. But, you got your reservoir, usually even on pictorial, they've got it, the name written on it. You got the reservoir, motor, pump, relief valve, which is what we looked at a while ago. Going to the control valve, see, they're not showing you different directions in the control valve. Little manual. This is, the little needle valve, basically, which shows why doing this, this is going back to the reservoir. And then flow, check valve. So, and I don't, like I'm saying, believe me, this is the first time I've ever seen that symbol or that one. When I saw it in the book, and I've seen a bunch of them, so they're not gonna look exactly alike everywhere you go. Other than schematic diagrams, two other kinds of diagrams are pictorial and cutaway drawings. Pictorial diagrams show the external shapes of components in outline form. It shows the position of each component in the system, but not internal parts. Cutaway drawings show internal parts, internal shape, and the internal working parts of the system, subsystem, and component. That's more your cutaway. Found me something there. Flip it on through this. So that's your pictorial diagram. Schematic diagram.
Went back.
This is cutaway diagram, which is a pretty good diagram. This is pretty good. It shows you the cylinder. Well, let's get over here. Filter down in the tank, which can be or can't be. It could be located above the tank. Motor, pump, relief valve, which is more complicated right there. Coming over into your manual valve, control valve. That's back to reservoir. That's that little tank that we saw earlier. Coming straight to the cylinder, to the front of the cylinder, and it's regulated going into the back of the cylinder. So there's your valve, check valve, coming back into the cylinder. So, all right, we're gonna get on piping schematics. Now those pneumatic hydraulic drawings are, that's something really get you, maybe Google it a little more or whatever, get used to it, ready to get on the job out there. It'll help you out, understanding how it works. Piping schematic. Piping arrangement for carrying fluids is a major part of many systems, and these diagrams, a double line is used to show the piping. These drawings show valves and fittings as drawings instead of symbols. Simple piping schematics show pipes as a single line. Standard symbols indicate the valves and fittings. Piping can be drawn in two ways. Orthographic diagrams show piping in a series of two-dimensional views seen from 90-degree views. Isometric diagrams show piping as a single view that includes all three dimensions. This is just a simple drawing of this is a washroom, okay, sink, drinking fountain. That's valves. You see the little X with lines on the end, that's gonna be a valve. And it's got 1, 2, 3, they've got them numbered. This is your main valve, more main valve. This is coming into the washroom. So that was going to the sink, production area, drinking fountain.
So the piping schematic like a blueprint, you see on a blueprint of a building or something?
Yeah, that's what you'll see, it looks a lot like.
You gotta have the piping layer where you see just the piping, and then they have the piping and electrical layer where you see them all, really how they work together.
Right, yeah. It's something I want, in case it don't touch on it, it may touch on it. You ever see, I think, you see a line I say this confuses too, and then you see this line come right here, what does that mean? Right there,
No.
Mhm. You see a line, and then you see it do this, what does that mean?
It jumps over it.
It's laying on top of it, or it's up, you know, it's just crossing over somewhere. Just keep that in mind. Okay. Lubrication systems for air compressor. Something y'all probably would never get into, but it won't hurt to know. This is like a typical air compressor, and it's showing you main bearings. I don't even think I put a question in there about it. But, crankshaft, oil pump, most of them have their own pump that pump the fluid through the system. But this is a good drawing, a good diagram. It shows you the flow of the lubrication, sump, out, water drainage, water trap, oil cooler, water inlet to the cooler. Well, this is, it has a cooler on it, it's cooling the fluid, the filter, and then it comes through and it's going to each, bearing, lubricating it, and coming down to the sump, and back out, and going through circulation. It's like it's got a radiator type setup. Hydraulic circuit schematic. Now, this is remember the valve I was talking about earlier? Where's the little man? They fired him. He didn't like coming in on time, so they fired him, and they found a solenoid that didn't argue, didn't want to know what the brake was, didn't want to know if he was gonna get a raise,
Didn't go home?
didn't go home too early,
He can go to sleep on the job.
didn't go to sleep. Well, they will go to sleep. They'll quit. But that's a solenoid, that indicates there's an electrical solenoid there. It's pulling that valve,
The
operating
rectangle
that
with
valve.
the rectangle with the line, the diagonal line?
Now, that says it's a four-way valve.
Right. I wasn't really gonna get in there with y'all on that because that's when it gets deeper and deeper and deeper. You know, it's called, it'll operate four ways, 1, 2, 3, 4. Four different ways. The flow going in this way, and the flow going that way too. And when the solenoid pushes it over, then this one, these turn up like that, and then you got this way and that way. So, 4 ways.
And that's just showing the return to the reservoir.
But now, you get a 6-way, 8-way valve, you get to look at one of those, you get, woo. Especially when they all go to just maybe 2 cylinders. Because you may even have a cylinder, and you like an assembly line or something. Alright, I'm just gonna say like, put the car door on the car, assembly line. Alright, when the car gets there, they want to shoot that door up there real quick, you know, and they go, both, but then they want the 2 cylinders, 1 cylinder to open the door, and this one to come away from the door. So you got several different things going on with the same cylinder, and that's why you got to have a valve that's got multiple directions. And I mean, they're out there, it's crazy now. You get, well, I guess the Megatronics, you know, robotics, they work, that's what they do. When you see a robotic arm working, I know y'all seen them. I mean, it's a series of valves little going on in there, and it's pretty complicated. So anyway, there's your cylinder, there's your 4-way valve with solenoid activated. All right, coming down here, the reservoir, filter, pump, motor again, relief valve. That, what does it look like?
No.
It's a pressure gauge. All right, just a while ago, we talked about what that was. That's just a valve. Probably a valve put in so you can, excuse me, either take the pressure gauge offline or to replace the pressure gauge. A lot of times we found it was, unless it was a pressure gauge that the operator needed to see, we could close it off instead of leaving pressure on the pressure gauge, because the pressure gauge, they will not, I can say blow up, but they're designed, where they're designed and all, they'll leak, they'll get bad pretty quick. So you better leave the pressure off of them if you can. Alright, line coming up into the four-way valve, into the cylinder. Don't know what it means, conveyor, maybe it's operating the conveyor or something. But, that's the circuit schematic. That's when you got electricity involved. Pneumatic circuit diagram. Filter, compressor motor, pump, receiver tank. That's your tank on your air compressor. As you can see, you don't see nothing coming back, you don't see that reservoir. This is strictly pneumatic. Come up through your valve, muffler, which you don't have to have on hydraulics. This is the pneumatic, you got and it's pretty loud, you put a muffler on it. This is the configuration on that diaphragm pump, we looked at the video on. On the engine cylinder, and coming back, that is kind of your reservoir tank, but it's not a reservoir.
More of a discharge.
It's a discharge, it discharges it out the atmosphere, it's through with it. You can't, we had a engineer one time come out there and he come on this idea, he was gonna save the compressed air. Yeah, we had, heck, were you serious? He said, I'm gonna come up with a way to do it. All right,
Somebody took the gas out of somebody expelling gas, remember?
2 years later, he's working for the highway department or something. But, anyway, that's how pneumatic works, just one line, does its job out in the atmosphere. Pneumatic hydraulic circuits, schematic. Okay? Sometimes you'll have pneumatic valve operating your hydraulic valve. Instead of having electrical solenoid, you don't see this a lot. I don't know if we had it all out at the plant. The fluid power system work is performed by liquids and gases under pressure. If the fluid is a liquid, oil, for example, the system is called a hydraulic system. When the fluid is a gas, then air is considered a gas. For example, the system is called pneumatic. The air supply going to the control valve, and you see it's got it showing what direction. How many way valve is that? The other one's 4-way.
Two-way.
Alright, and that right there, even though he ain't got a head on him, he lost his head, he's still one man. Spring right there. Coming in, air, is compressing oil,
Right.
and then coming into, your flow control valve, check valve, and the bottom cylinder coming out. That's just not a preferred way to operate a system. But you do see it someplace. When reading hydraulic schematics, remember the following. This will help you read the diagram in the easiest way possible. Use a step-by-step approach, read the symbols carefully, look for the pattern of flow, look for regulators that work only in certain directions or under certain conditions. Now, this is the electrical schematic for a truck. We're not gonna go over this too heavy. I know Lee, should have had y'all electrical schematic. And don't want to confuse you with this because you're probably not gonna work on trucks out there down here, especially electrical. But anyway, it's a pretty good drawing. Especially the way, I like this drawing laid out better than some schematics. Some schematics has got them going like they are, running across each other and every which way. So this is a pretty good drawing. Shows you where your tail lamp's running. The only thing I see I don't like about it is showing you wire cut. No, it's not a good drawing. You don't show the wire cut. wiring diagram of motor starting circuit. Some devices on an electrical schematic are sub-assemblies. They are drawn as single devices, even though they may have many internal parts and wires. These are outlined with dashed lines in the schematic. Separate sheets show the internal drawing of each sub-assembly. Control sub-assemblies are shown in the order in which the controls are activated, relay coil contacts are marked on the diagram. There again, this is another electrical, I hope y'all gone over this, so I'm gonna go over more with L1, L2, L3. Start, stop button, coil. And power coming to the motor, T1, T2, T3, bringing in the power. Run the motor. Pretty simple drawing. What are these? Heaters? It's heaters in your starter? Don't tell me now. Y'all gone over this, that? I mean, maybe y'all may not have touched on schematic yet, I don't know.
We
Thermal
touched on
overloads.
them, but
You
we
didn't
haven't-
tell us
Thermal overloads.
We haven't really went into
in depth.
motor controls and stuff in depth yet.
Okay. Well,
The
y'all-
little hooks are supposed to be thermal
I
overload.
won't confuse you, we'll let Lee give y'all a good rundown on that. Schematic diagram of motor starting circuit. Wiring diagram shows the relationship of devices in the electrical system, it also shows how the system works. These diagrams don't show the electrical connection in a way that's easy to follow. Schematics are usually used for troubleshooting electric motors and other electric equipment. And they knew what it was saying when they said that on a lot of schematics I've used and all. I work on golf carts on the side, well, I used to, I'm trying to quit, but, and electrical ones are the ones making me quit, because the government has come in, and no more gas, gonna be all electric, and these electric golf carts, nobody builds them the same.
Well, the Yamaha electric one that I've got, you've got to have a freaking computer to work on the darn thing.
Oh, yeah,
It's like a car.
yeah.
If you don't have a computer, you can't adjust anything.
So it ain't, just don't just have a regular controller like them.
I finally got Wi-Fi at the house, and out of the shop, and I can take my laptop out there and it'll reach. And, I set the chair right there by the golf cart, I'm on the computer looking and I find one that's, hey, bump this, this is aggravating. And, some of them can be just as, I like for them to come in and be putting new wires on and tighten up some necks, clean some necks, and let them go down the road in good shape. I got those computers on, control boxes, and some of them's got the control box, PDF, is it PDF that, when you go downhill, it slows itself down? Oh, that's a killer.
That's what they usually got, the stuff that recharges the batteries on it, too, use the resistance to recharge the batteries.
Yeah, and all that, so I give up on working on them. And it's because you can't get a good drawing, even when you go online. The best way I found is get on a thread where these guys are talking back and forth, hey, my golf cart's doing so-and-so, what do you, blah, 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 blah. I found this so-and-so, and changed it out and it worked. But when you go try to find a good drawing or schematic, it's not there. So, matter of fact, I had 2 electric carts I was going to rebuild and sell. This past weekend, I put them on Craigslist, what I paid for them. Saturday, the guy come pick up both of them, I was happy. I said, bye-bye. So, but anyway, you can learn them, you can learn how to read the drawing, and once you get to be a proficient electrician and all, it comes to you and all. It's still time consuming to figure out a circuit and do it right, and that's with electricity, you got to do it right, so. All right, a lighting diagram. Now this is a pretty good diagram. I mean, it's for us lights. This light in here, this is there in a line, a signal. And it's showing you where your lights are going to. This basically it. Many different kinds of drawings are used in troubleshooting lighting problems. An electrical diagram for the building shows the location of receptacles, panels, and fixtures. Building drawings include detailed layout of the lighting fixtures, including main directions. Specification sheets show the kind of electrical service and how the service is installed. The sheet also shows locations of outlets and wall outlets. And just to touch on that, another thing that Leah probably covered real good, lights are not created equal. I found that out, especially this day and time, because government regulations change stuff. You can't just stick any bulb up there in the fluorescent light now. You can, but it's either not gonna burn right or it's not gonna last long at all, because you got, some of them now, you take the ballast out. Straight in, put them up there with the ballast. If you didn't know that, you stuck that bulb in there. And you're gonna use more power, or you're gonna burn up bulbs. I don't know, I'm not sure how that works. I didn't know light bulbs when they got high. Lighting control diagram. Okay, this is just a basic lighting control. Transformer, switch. That's normally open, right, when it's not making contact. If it shows you that, that's normally open switch. What's a light switch, it's supposed to be normally open, that means off. And that tells you what's happening when it's off, what's happening when it's on. Control power. Like I say, Leo, get y'all with me on that. That's the troubleshooting part, sure. Alright, so I like to find one of these now. If I do get a hold of one of these on when I'm troubleshooting a golf cart or something, it's pretty good. I did get one that was on a controller on an older club car, and it come with, I printed it out, took it home, and was able to troubleshoot that cart. But it said, try this, if that don't work, try this, if that don't work, then try this, if that don't work, then it's this. And sure enough, it was a controller, and I went through all the steps. And if you find one like this, that's pretty nice to have. And that was actually written by a guy in one of those threads. You know, he read it and he said, read this, I come up with this, hope it helps y'all out. And I was in a PDF file, ready to print it and use it. An important diagram for troubleshooting specific pieces of equipment is the troubleshooting chart. This is developed by the equipment manufacturer. This document will give you step-by-step instructions for troubleshooting the equipment. And that scared me right there, that part right there, manufacturing. It's probably fairly comprehensive, so, you can go by it, it might work pretty good. Always be skeptical of something like that. I mean, just don't let it drive you crazy saying, well, if this is not working, it's not gonna work. Look at the last one. Okay, now, I want y'all to take the pre-test. If there's questions that didn't come off of this, don't panic,
Post it.
take care of it.
The post-it or?
It's a pre-post. You took the pre.
Yeah,
I'm getting right this time, don't confuse me. I was calling the pre-post earlier.
Can we take a break for?
Yeah, y'all wanna take a break first? Yeah.
My brain's fried.
Something you could possibly see a lot of in your job, or you may have a job and you never see one. But if you do see one, it's nice to know how to read it, or basically. This is a blank drafting sheet. This is what it looks like before you get started. This little box in the corner is, and this is an uncomprehensive drafting sheet. I mean, they're not all the same. There's nothing really standard about them. But this little box in the corner is very, very helpful. This contains most of your information. You put your drawing up here. It's got the spot, approvals. You got who drew it, what company. Right down here, I place materials, what type of materials it is, or it's built out of. And it goes on and on. This just gives you the important information about what is in the drawing that you're looking at, so. I always use that, a lot of times people just grab the drawing, look at the drawing, and try to figure something out. Need to come down here because sometimes they'll make a change in the drawing, and you won't know it. So you come down here and read in this box, and it'll tell you if they made a change, supposed to tell you if they made a change. What did you like that? All right, scales on blueprint, and that's another thing, that it will tell you, I can't read it real well, the scale is right there. It'll tell you what scale it is, if it's 2-1, 1-1, whatever, and this is a chart that you're gonna keep handy to tell you scales on the blueprint. Not really keep handy, but kind of know that it is important to look at the scale. Because it, you know, it could have 1 inch could represent 10 foot, 20 foot, and so on. So then you'll need to know. This shows you civil engineer and architect, and mechanical engineer. Why are they all different? They wanna be, I guess. It just, I don't know. I guess to differentiate between each other, I don't know. That's the way it's always been. But, it shows you the scales, and it means object is drawn at. It tells you what to read, like I say, right here, for example, half inch equals 1 foot. They use 12 inches equals one foot, which it is true. I mean, 12 inches is 1 foot, 6 inches is 1 foot, but it could be any of these, so it's gonna be in that, little box right there, written, so it's important to know that. Standard size of blueprints. There's a letter designation for the size of the sheet a drawing is made on. The above table lists the standard sizes with their corresponding designations. Not very important to you, it just shows you that what size the print's supposed to be. Okay, the sign-off block provides space for signatures or initials of those responsible for the drafting, checking, and approval of the document. Each person must sign and date the document on the appropriate, when their work is completed or approved. Should be on the appropriate spot or line. In the upper right-hand corner of the drawing, there's a revision block. This is used to note changes that have been made in the drawing after the final approval. This location is placed prominently because you need to know which revision you're using and what's been changed, along with whether the changes have been approved. Revision. So, yeah, that's why you need to look at it, so something's changed from the last time you built it or used the drawing,
I got a question for you.
okay?
Okay. One of the questions on that, test was about the, sign-off block. And I thought that one of the answers was it provides a place for a signature or something, and it counted it wrong.
That's for revisions.
Do what?
So, one was for revisions and one was for approval.
One is for approval.
One was for approval, the initial drawing, then when you get a revision, you have to update the
So
initial.
you got,
Approval of the.
revisions and then approvals.
It still provides a place for signatures, and that was the answer.
Sign up blank.
All in the answer,
Sign up blank is approval of the.
I know what I'm saying, the answer I put though was it asked what does the sign-off block provide, and then, one of the answers was a space for a signature.
The question was
And it
what?
counted that wrong.
Question was
What
what?
was the question?
What does the sign up blank indicate?
What does the sign-off block indicate?
It says the sign-on block provides space for signature.
Yeah, but
What does it-
provide a space for signature, that
But
is.
what does it indicate is what the question asked.
Yeah.
Yeah, that's not.
It indicates that it's.
That indicates the approval.
Yeah.
It indicates approval.
I mean,
You just can't sign it.
Yeah.
I mean,
We'll
it is a
look at-
place for a signature, but
Yeah, but it asked what did it indicate, not what it was for.
it indicates that it's a place for a signature.
It indicates approval.
Okay.
That's how you got it wrong.
Was approval on there?
Okay.
Yeah.
Approval of the-
We'll take a look at it. Boy bar holder, okay? I don't know why.
Yeah, I didn't understand that one, that's why I was.
They wanted you to see boy bar holder.
Yeah,
That's all I know. Drafting symbols. I don't expect you to, memorize these unless you get it in department where you're gonna read a lot of blueprints, you will eventually memorize them. But, it's nice to have that chart handy if you, get a hold of a blueprint, so. Thick lines, object line illustrates all visible edges of the object drawn. Cutting plane line shows where a section has been taken. Arrows indicate the direction in which section has been, is seen and accompany a cutaway view. Hidden lines show features that cannot be seen. That'd be like a line that's in the ground, buried in the ground. Center line locates center of round features. Thin line interrupted by short dashes. Center line. Extension line extends from object to dimension lines. Dimension line shows the intent of a dimension. Example, it's 20 inches from this point to this point. Leader, like a dimension line, we usually have a note on the other end. Phantom line shows positions of a part of an object that moves. It'd be like a shaft. For example. Assembly drawing. There you go. That's a good drawing. It shows you plate, shoulder, screw, body, post. It's made out of steel. It's a boring bar assembly. That's for lathe drawing. It was, they don't have approval signed on it, but somebody was supposed to approve it. And, up here in revisions, I can't read what it says, but that's where a revision would be. I don't think it don't have a revision up there, but anyway, that's where your revision would be. So that's a good little drawing out there from machine shop. Perspective drawing. All right, this is it's getting a little deep into it, we'll just breeze right through it. Don't cloud yourself with this. Vanishing point is showing, when you look at something, like I say, I'm not an artist. When you look at a drawing, and I had a friend of mine that he still is an artist, always told me to draw something the way you see it. And you can draw anything. So that's easy for you to say. But you know how somebody tends to draw a house and they draw it like this, and then like this. Somebody tend to do that. But that's not the way you see the house. You see the house. And now I probably can't draw it. That's the way you actually see it in the corner. So you don't see all four corners back here. You can. I mean, I know it's not a good drawing. You see what I'm getting at? That's the difference in the drawing can be, if you're standing in front of it, that's exactly the way it looks. That's what I'm getting at. You know? So that's the way you got an angle going that way. Say that's some lockers, or you walk into a room and there's boxes in there, that's the way they're gonna look to you, so. Perspective drawing. Orthographic projection. So we get pretty deep into it, but this is just telling you certain type drawings, I don't know the correct terminology, but, you know, some drawings are plain, some are real with depth, some look like a picture. So just, you wanna figure out which way you're looking at it, make sure when you're looking at the drawing, sometimes you look at a drawing, I've seen drawings with like a shaft. And it's got threads on it, when you see it's bigger here than the other, it's bigger on one end than the other because it's showing it to you in an angle. If this imaginary box were open and laid flat, you would view all 6 sides of the block at once. Even though the 2 dimensions are shown in the single view, you need at least 2 views that are 90 degrees apart so you can show all 3 dimensions. The 3 views shown are top, plane, view front, front view, front elevation, and right side, right elevation. The object is usually drawn so that its important features appear on the front view. So, if you're looking at this, and the machine shop's gonna build a box out of steel, you can't, just draw in the box and, whatever you got going inside it, it's laid out like that. Just, comprehensive stuff that, you probably won't never use. Auxiliary view. At times, 3 views may not be enough. This drawing's purpose is to show the size and shape of each surface. The surface of the drawing is to show the size and shape of each surface. If the surface is not 90-degree angle from the other surface, the drawing will not show its true size and shape. The designer was able to overcome this problem by using an auxiliary view that is not one of the related views. This auxiliary view surface without distortion. Orthographic projection of a 45-degree elbow. That's good. This is what I'm talking about. Y'all know what a 45-degree elbow pipe fit. Okay? And this is side picture, what you look at, when you look at it on this end, and when you just looking at it straight on the flange. That can give you all the dimensions, because they didn't put dimensions on here, but you would on a drawing. Partial auxiliary view of a 45-degree elbow. It's just showing the side and the 2 flanges. Types of sections. At times, the auxiliary views can't show the information clearly enough. This happens when a part, this can happen when a part, okay, twice, has a special cross-sectional shape that can't be shown clearly using standard orthographic views. This can be overcome by using a section to make the section. The designer draws a cutting plane line through the object line. The cutting plane line shows where the object is cut to reveal what's inside. The arrow on the cutting line shows which cut surface you are looking at. And again, this is pretty comprehensive of getting in there, but it's just showing you different types. Pictorial drawings, okay. That's what I was trying to tell you about that. Isometric and perspective. And all that means is the isometric, see if I'm giving you a dimension of that house, I want built, and I want the roof 10 foot here and 10 foot there, or 10 foot here and 12 foot there, or vice versa. You don't want to draw it like that. Some houses you'll see with a roof, but you want to draw it like that to get that dimension to show that one roof's longer than the other roof line. And perspective is the way I would draw it on the board best I could. Isometric drawing of a 1-inch cube. It's showing you the top, which the top and the bottom should be the same. because it's square. 1 inch, 1 inch, 1 inch. This is telling you that every line is 1 inch. Isometric drawings, isometric means equal measure. The name refers to equal angle measurements. Isometric drawings are based on 3 isometric axes, which join to form 3 equal angles, each 120-degree angle, as shown above drawing. The sides of the cube are square. The circles are circles, but aren't shown that way. The positioning of the object changes corner angles. Make certain dimensions seem larger than they are and changes circle into ellipses. However, each dimension is held to scale as long as isometric axis.
Awesome.
That was, without lack of better word, telling you more you probably need to know. It's just to give you a little brief rundown on drawing. You know, you can learn to read a drawing, it just takes a little bit. But introduction to blueprint. And believe me now, I'm going through the pages, that was just a small portion of it.
On the test, one of the questions was what indicates the size of the drawing in a standard title block? It tells you that you do use the letters for the size of the paper at the very beginning, but it doesn't tell you about the title block.
There's a difference between size and scale though.
That's what
The
it says,
size
what
of
indicates
the size of the drawing
in a
is a
standard
letter.
title block.
The size of the drawing is a letter.
No, that's
The
the
scale-
type of the paper that it's on is a letter.
the
of
size.
No, it's talking about the size.
Size.
Standard
That's
size
the size of
That's a
blueprint.
blueprint, not a title
There's a
block.
letter designation
Yeah.
for the size of the sheet a drawing is made on.
Letter A indicates that size.
8.5
E indicates that size.
But that's not, that's the paper that it's on, not the title
drawing.
block.
The size of the drawing, how big is the paper that the drawing is on? The size of the drawing, not the scale of the drawing, is what it's talking about.
There's a letter
Because I thought that,
designation
I was
for the
gonna put
size
that
of
on
the
the
sheet
pretest,
the
and
drawing
I
is
said
made
that,
on.
you know, that's not the
There's a
title
difference,
block.
there's a difference between the size of the drawing and the scale of the drawing.
What are the symbols you
What
use?
indicates the size of a drawing in a standard title block?
The left,
In the title block. What is in the title block? What is in the standard title block which indicates the size of the drawing?
the left, it's a letter. It's a letter.
What is in the title block? Title block. B, right there.
That's the paper that's.
That's the size of the drawing. There's a
Size
difference
B.
between size and scale, is what I'm trying to
Size
explain.
B.
If you've got a blueprint,
So she's
the size of the blueprint is gonna be that letter scale, the size of the blueprint. The scale of the blueprint is gonna be printed somewhere else on the blueprint.
Scale is right.
The scale is gonna be a,
That says full
1
scale
inch
there.
equals 1 letter, can't be.
Scale is right here. It says
it's
full.
full. But this is the size of the blueprint is the letter, not the scale of it. See what I'm saying? It's
Yeah,
two
but I
different
mean-
things.
I think what they're saying is sheet size is the same thing as drawing size.
Right.
That's what I was confused on that too. I think it's,
Yeah, sheet size is the same.
See, it
as
asks for
drawing size.
sheets, it asks for one way on the test, and it
It
explains
tells
it
you a different way in
it's
the,
different
yeah.
way from there.
So that could be.
Because that just, you know, because
Your
title
drawing,
blocks.
your drawing size is the size of the drawing, how big the drawing,
Which one?
I can't remember.
not the scale of the drawing.
Yeah.
But
the
I
way
know
that
that
it
it's
explained it.
relative to what I'm talking about. I don't know the name.
Most of
It's
your
still
blueprints
10 points.
Big.
What label it defines orthographic view that shows the most important features of the object.
For the front.
I'm in trouble.
There is.
No, keep clearing it.
I don't know. I
I'm
can't-
waiting for the post test.
No, that's, I have to go back and look at question, I can't remember exactly what it was, but it's relevant to what we're looking at now. Yeah, cause it could have been, exactly,
Yeah,
yeah,
it does.
yeah. I think I heard it right, but I'm not 100% certain. So I had to ponder that question, because this right here sort of contradicts what the first one said.
Yes,
Because it says here,
that's what the
until
bond
the
says.
technical
We may do
power
three of
source
them
is
But it's not
turned
approved
off.
until it's
That was
signed.
one of the answers. It's right there to tell you what the tech power source is.
Well, I mean, if it's not approved, it wouldn't be there. It's not approved.
Also tells, yeah, yeah, also tells the different components of the system. See, you had two answers on the last one that were both of these questions, basically.
Well, it has, it's not asking a very.
I won't explain that right, really, it doesn't matter.
What is the signature on the song?
Wiring diagram.
Again, I know the.
I almost said schematic, and I went ahead and put some, no,
I put
I
schematic.
clicked wiring diagram.
I put schematic.
I clicked wiring diagram, got it right, so I went.
Huh?
We had to take-
Are you, or are
I
you?
stay that way.
Are you? They probably are.
I'll be honest with you, just stay that way.
So,
Keep getting told my password is wrong.
Huh?
I keep getting told my password is wrong for the post tip.
they're all supposed to be chat, whatever,
Landry.
I mean, they're all. We can find out. Chapter 11 might be hard.
You should say that.
Yeah, we're gonna do three today.
Still says I'm wrong on the password. How do you put that in there?
Put your P.
Huh?
Capital P.
Capital P.
We have, they do a capital.
Capital, capital C.
Capital C.
Yeah, capital C. I can't do that.
Space, 10.
I'm fine with
That's the time.
It works for me.
wrong. I'm turning,
Are you putting spaces in?
I ain't even got to the text, I'm just trying to go through. I had to go all the way back to the home page and then go back.
It took you about 2 minutes to look into it.
I just tried to log in and it told me access denied.
I'm glad I did.
It ain't gonna
Made
be
that, I sure did bad on that pre-test.
Hey, man.
What'd you make on the post?
Hungry.
You help a friend that one?
That's what I did that second time.
I'm glad it let me.
Well, I forgot that question.
Wanna hit, we need to do three on chapter 11.
Yeah, but I didn't wanna do the post on chapter. That's why it wasn't letting me. I was in the wrong place. There we go.
power phones?
I'm in a minute, I can do it.
You are?
Oh,
Is there a
it's
second
fun.
little bar? Show a second window? Oh, no. So that mine was running slow, but it had an update, and I let it finish the update. As soon as it finished updating, it spit back up.
All right, in many ways, the symbols that are used in schematics are like the letters of a non-English alphabet or the signs used in mathematics, which this is great to me. Let's look at the symbol of triangle. This is the Greek letter delta, and mathematically it represents a change or difference. Figure 11.1 on the following page uses the delta or triangle to designate common electrical connection, as shown below. Connection point. What I'm reading into this is all of these are connection points. Circuits can either be grounded to earth, ground, or to metal frame commonly called chassis ground. The symbols are connected in a meaningful way. Greek symbols are combined to form words, then sentences. Schematic symbols are connected by lines to represent the system. There's an electrical schematic. Like I say, I'm just gonna run through this, because Lee's gonna cover this a whole lot more than I will. And he'll be a whole lot more efficient in doing it than I will. There's a motor, switch, and I really don't know what that represents, but that is what they're talking about, the connection point. Schematic of electrical control circuit. Electrical schematic using pictures. That shows you that's not a diode. Fuse. Yeah, it looks like fuse. Pump, motor, another pump, like a vacuum pump, and a heater. Electrical schematic using only symbols. Schematics are necessary to the electrician when repairing a schematic, a system. The schematic is used to troubleshoot the fault. The diagram can tell the tech where the power source is or where to turn it off. It also tells them the different components in the system and how they're connected. This allows the tech to make intelligent decisions on where the problem may be. Finally, after discovering the problem, they'll see how to make corrections needed to restore the system back to operation. Which means putting in a jumper or, crossing something out, bypassing the fuse. So that's what that schematic is, just troubleshooting schematic. There's a cutaway diagram, we kind of get back to, hydraulic system and pneumatic system now. This is a cutaway diagram, which we kind of went over this before, it's kind of repeating itself. There's your tank, the reservoir tank, remember the little square thing that shows you represents? Well, that's it right there, except they don't put the top on the other drawing. Filter, pump, motor, fluid line, valve, cylinder, flow control, check valve, flow control. Pictorial diagram, basically the same, pretty close to the same as you see the components, except they don't draw the two lines for the pipe, it's just a single line. Pictorial diagram is a single line drawing shown with simple outline drawings representing the component of the system. Figure above shows a pictorial diagram where the components are listed. We got it. This is a real good drawing, really got an A as reservoir, telling you everything. A right angle check valve. Another schematic diagram is the same thing. We were looking at three things that are all the same, just different type of diagram. This one is what you'll see most. When you get a new piece of equipment in, and I give you a schematic, it's gonna look more like this one than any of these. I'm not gonna go through the trouble of making a drawing like that, I just wanna do it. It's this drawing here that you'll see. The schematic diagram is a single line drawing in its true schematic. Above diagram resembles a schematic diagram. Notice the use of symbols. A schematic is the most important diagram to the maintenance specialist. That could be true. Combination diagram. That's got drawings and schematic in it. Drawing and symbols. Combination diagram will be part of all three diagrams. The above combination diagram, these are occasionally used on the job. Like I say, there's nothing standard about it, the drawings or the symbols. You're not gonna, you don't see the same thing twice all the time. But as long as you know the basics, you can pretty much get around it. Single line piping diagram. That's your pump, fluid coming through, going this way, coming through, that's a reducer, a bushing, that's your fittings in the pipeline. Valve, cross plug, that's good, union. I really don't know what cross, unless you got a cross in the
It's
line.
a cross in the line when the plug in.
You got it plugged, I put a flange on. Double line piping diagram, that's just a picture of a pipe. Interruption in flow usually produces an obvious sign. A simple DC circuit. There are two ways that electrical current can flow. Current that flows steadily in one direction is called direct current. To understand the flow of electrons in DC current, the source must first be located in the schematic. Then follow the paths of electrons through the wires and devices to the other side of the source or ground. The above schematic shows the current flow in a simple DC direction. This is something we'll go through with Lee probably the next couple of months. Simple AC circuit. Many circuits use current. When it started off, what was Edison and Tesla. Edison liked DC, Tesla liked AC, wasn't it?
No,
Introduced
Edison
AC.
like DC.
And he got a lot of backlash trying to implement AC current, which is what we use today. Many circuits use current that flow in one direction, then reverse and flows in the other direction. This is commonly called a cycle. Typically, there are 60 cycles in a second. This type of current is called alternating current. There are no positive and negative signs in an AC current. To be able to trace current flow, you must look for other labels. The most common label is L1, L2, line 1, line 2. Common colors are black, red, and white. The above drawing shows a simple AC circuit. So, AC and DC are different. Arrows show direction of flow in a piping system. All right, this is indicates a 3-stage air compressor. 1 stage, 2 stage, 3 stage. And it's basically like 3 pumps in one. And goes to the tank, drain valve, two receiver, and all this is a relief valve assembly for a filter and a separator. That should be indicated on a drawing when you have a filter and a separator. Supplementary diagram shows reverse flow direction. cylinder we talked about earlier, reservoir, we got pump over the valve. It's coming from pressure line, control on up position. That's your valve. I don't like this drawing at all. I'd rather use a schematic drawing than any look at it. But, alternate flow is sometimes shown in a separate, smaller diagram. The main diagram above shows the flow when the control valve is up. So you've got it in the up position, down. The valve also has a down position which reverses the direction of the flow in some pipes. This may be shown on a supplementary diagram next to the main diagram. The above drawing shows this. Typically, the arrows won't be as obvious as they are above. The flow and piping schematics are usually shown by arrowheads drawn directly in the lines. Okay? Nice and boring stuff. Let's do it. Do the post test. And, probably won't start another one, but I want to recap on a couple of things.
So we'll go ahead and do a post on that.
Uh-huh. So it does skip chapter 12 and 16, so y'all pay attention to that. Right. Study them all, I don't care. You're not gonna hurt yourself.
Says skip 12 and 16, you said?
Yeah, it skips.
Oh,
You
okay.
don't have it, I mean, it's, you're gonna look at it right there anyway, so. You don't have the book.
I misunderstood what you said.
So if I tell you chapter 12 and it's not in there, then that's not what we're gonna go over.
Now, how in the world did I miss that one? I picked the same answer I missed, picked on the first. It was right on one, wrong on the other.
You have to be careful how you pick those things.
That makes me mad, I made better on the free than I did the post.
Which one is it? We got right at ten.
If a piping system can have more than one flow arrangement, how are the others shown in the schematic?
Same as for maybe
Y'all get through with it, see what trip you
Chapter 16 more, 12, and 16.
I got it. First.
He said study number 12 and 16. No.
That's why I
It's
asked you
16.
about the
There's a 12.
Gary, my post did great, but he
I'll let
has
you
no.
break
did them all.
I do the apology.
It's not 12 or 16.
If it ain't in there, don't study. Unless you figure
We
out
got
what to study.
14.
If y'all, somebody wants to borrow this book, just to study it for the heck of it. Y'all, because we gonna deal more with pumps than anything else we've gone through. I told you about, what did I tell you about troubleshooting pumps? Well, it was three main problems. Anybody know? What's the three main things that go wrong with the pump?
Oh, the motor
The inlet.
and,
Cavitation.
Cavitation,
Bearings? No, seals?
Well, we didn't talk about bearings, and that's what I want to talk
Seals?
about.
Seals.
Loss of suction, loss of discharge, and cavitation. I mean, that's the three basic things. But, what I wanted to tell you, I was telling you about that, but that is the bearing. That's why I can't find it.
Where's the old coffee maker? Look at this newfangled. All you gotta do is put in your order and it does the rest.
Centrifugal pumps.
Okay, we're talking about a pump, on centrifugal pump. The main pump we're talking about, and when I want to touch on that, we're talking about you losing suction or discharge or cavitation. You also have a bearing problem, and it can grinding noise, making noise. The way you would troubleshoot that, and this would have to be on a pump that you can run dry. You can't do this on one that absolutely positively has liquid in it all the time. And there's very few pumps out there like that, but, magnetic drives, you could run, if you run them a minute without fluid in it, that's gonna destroy them. Cause the drive is lubricated with the fluid pump. But anyway, you, on any centrifugal pump, it should have a drain valve on the bottom, should. Most of them come with them, most times we install them. You go out to that pump and you do a little troubleshooting, usually, a lot of times our mechanics, the first thing they would do is close the discharge valve, close the suction valve, open that drain valve, let the fluid drain out real good, and then turn the pump on. And if it's sitting there growling and carrying on after he does that, then you don't have to go no farther. You got bearing problems. It's not a liquid problem. So I wanted to come back and touch on that, because usually where you can, now sometimes they want you, hey, we're running production out here, come listen to this pump so you can tell what's wrong with it. You're gonna get that more than you are. It's not running. That's when you wanna try to listen and do the troubleshooting I was talking about with the flow. Figure it out. But if you go through your troubleshooting and you can't figure it out, a lot of times you can feel a hot bearing housing, you know, or you can use your vibration analyzer if you got that up, available. But that's just another thing I want to touch on with that, was just to remember that bearing failure also. Something else I want to show y'all, this is something you might use. You might use it at work, and you might use it at home. Some of y'all may already know it. And I don't want, and it won't only be used for this, but I'll give you an example. You have a sheave that's 10 inches. Okay? And you have a sheave that's 5. Somebody get the calculator out there on the phone. All right, first of all, you got diameter, radius, and circumference. Right? Okay, you got 2 sheaves, and I want you to put a belt on it. You got a belt, you got the motor here, and this is the pump, so we just installed it, go put a belt on it. What are you gonna do? You gonna go out there and take 30 belts out there and get one fit? We'll show you how to figure out how to put a belt on it, okay? And we'll use this in a lot more ways than this. Okay, diameter times pi. And what is pi? Always 3.147, but you just did 3.14. I learned this about 5 years ago. How important it is, just remember this number right here. You'll use it a lot. Okay, look how simple it is. Diameter times pi, okay, who's got 10 times 3.4? We know it's a 10-inch sheet, okay?
That's 31.4.
1.4. 31.4 inches around it, okay? All right, we got a 5-inch sheet right here. We measured it from here to here, diameter. What's that? Somebody calculated?
5 times
1.4.
15.7.
15.7. Okay, when you put a belt on a sheave, where does it contact?
Only contacts half the shoe.
Half the sheave, okay? Cut this number in half. Huh?
57? Yeah, 15.7.
15 point what?
7.
Cut this number in half.
7.85.
Yeah,
7.85, okay? Now, you get your tape measure and measure from here to there. Then you got this two measurements right here, okay? Let's say that's 10 inches. Let's say, no, let's do better, 20 inches right there, okay? I measured how far they're apart from center to center. That's 20 inches times 2 is 40. When you add these together, that tells you the length of that paper.
Where did the times 2 come from between?
The top.
Top and
Bottom
bottom.
and bottom. Measure your center to center, that's times 2. Well, we got 2 of them. And then you've done this in half, your circumference in half. You've got that measurement here, this circumference in half, you got the measurement there. You may not never use that, but it's interesting, and
Figure out all three of them numbers together and give you some length for that.
you can link that back. But I'll tell you where stuff you will use it in. My wife told me I want a fire pit, so guess what happens? That means she's gonna get a fire pit. All right, we figure out how big we want it, where we want it, and it's 4 foot. 4 foot from here to here. I go to Lowe's, and there's a young girl come out there to help me, tickled me. She come out there and I said, I'm gonna build a 4 foot fire pit, and I need it up with these bricks, you know, them funny shaped block to go around it. And I told her, I said, it's 4 foot wide, tell me how many I need. She stood there and said, I don't know, but we'll lay them out here. And she was willing to help now. She said, we'll lay them out here and stack them up and count them. And I said, all right, let me show you. So I showed her the formula, the diameter, and how to figure the circumference. And then we figured how many brick I needed. And she told me, when I told her all that, she figured it out. She said, wait a minute. She went and got a note, a pad, come down, wrote it down. She said, these boys around here, I'm gonna make them mad. She done got something on it. She said, cause there's a lot of people coming there and asking that. You know, I'm gonna build a fire pit. How many do I need? So she had one up on them, so she was tickled to death. But, you will use that around home, you know. 3.14, that's, y'all might explain it to me, I'm not a mathematician, but it's pi, and the way I figured it out was everything, the circumference of everything, when it gets bigger, it changes, but it's automatically equally divided in 3.14 sections. So, just something good to know when you, creating some things, and you might use that with some belts, but we used it out there at work a lot. And even doing that, you might not get the exact belt. Usually if you have, you pull the motor in, center of the adjustment, get that measurement, you're gonna get a belt, you know, it's the right size. Another thing too is, belts. And I don't know if we're gonna get on that, but belts have numbers on them, and the numbers mean something. I wish I had an example. I may try to bring one day, but Your letter D, it's a B, A, B, C, or D, that's the width. That represents width, and then the next number will tell you the length of
So
the belt.
the width is in the letter,
And
and
is
the
in the
number
letter.
is in the length.
Right, and I forget the width of the belt, but it comes, looks like on a chart, but, the numbers of the belt usually tell you. So, everybody through with it? Yes, he's through too.
Yeah,
Yeah,